class we are going to complete this. Why it's like this? Why? What happened? Austin, are you there?
Yes, sir.
Oh, what happened to this? Please do write elimination reaction. This will not be good. Elimination reaction. Just wait a minute, please. Okay, are you able to see the screen?
Yes, sir.
All right, elimination reaction. From the name, you can think of something is going to be eliminated or you are going to remove something. So it's very easy. First, I'm going to define it. Halogen atoms having beta hydrogen. I will tell you what is beta hydrogen. Halogens having beta hydrogen atom undergoes beta elimination. Undergoes beta elimination when there is a condition when heated with alcoholic solution of alcoholic solution either KOH, KNH, NaNH2 or KNH2 we can write NaNH2 or KH2. This is the reagent. We should heat in the presence of alcoholic solution of KOH, NaNH2 and KH2. So what the reaction will taking place? You can see this is your X and the bond is like this. Let's say this is your hydrogen and this is like this. Now see what will happen. The halogen the halogen connected whichever carbon, that is your alpha carbon, and the carbon which is directly connected to that alpha carbon, that is called beta carbon, and the hydrogen which is connected to beta carbon is known as beta hydrogen. Is that clear to everyone?
Yes, sir.
This reaction is also known as beta elimination. This reaction is also known as beta elimination, and you can see in the presence of alcoholic KOH or NaNH2 or KNH2, and when you are going to heat it, you know what will happen. This X along with H will be eliminated, and there will be bond between alpha beta carbon, double bond between alpha beta carbon like this. So you have to first recognize which one is alpha, and the carbons. It is not necessary that there will be only one beta carbon. The carbons which is directly attached to the alpha carbon, that is called your beta carbon, and the hydrogen which is connected with beta hydrogen, that is called beta hydrogen. Is that clear?
Yes, sir.
Please do write it. This is your alkene. This reaction is also known as beta elimination. This reaction is also known as. Let me know when you are done with this. Let me know when you are done with this.
That's it.
Okay, now see. If I'm going to give you a question like this, CH3, CH2, CHBr, CH3. Tell me how many products are there, and if more than one, then which one is major product?
Sir, can you repeat the question?
Basically, you are going to react this with alcoholic KOH and heat. Tell me the product. products are. Two products. One is butane. Okay, very good, Austin. Umam, let me know if you have any doubt. Is it, Umam,
Yes,
will you be able to do this? Very good. So see, it's very simple. I'm going to write it like this, and in the same way, like this. Wait a minute. In the same way, it's this. So basically, all I want to say is that this is your alpha, this is your beta, and this is also your beta. So there are two product possible. If you are going from this and this, this and this, you will be getting CH3, CH double bond, CH, and then CH3. And if you are going to remove this and this, then you will be getting CH3, CH2. Then comes your CH double bond CH2. So you can see that this is your 2-butene or butene, we can say butene, and this is your butene or but1, in which this is your major product and this is your minor product, or you can call it basically, it is due to symmetry or Set-Jeff rule. Set-Jeff. What does this Set-Jeff rule says? More alkylated group, more alkylated alkene, more stable. More alkylated alkene, more stable. So you can see it have two alkyl group, and whereas when you are going to talk about this has only one alkyl group. So in this way you can see say as well, if you are not able to find symmetry easily. Is that clear?
yes,
And again, the reactivity, if you are going to see about the reactivity about the living group, it will be the same three, not the living group, alkyl halide. 3-degree Rx will be more stable than 2-degree Rx than 1-degree Rx. Is that clear? Please
yes.
do write it. Let me know when you are done with this. Both of you done with this?
Yes. Yes.
Now see the next reaction. I'm going to give you this reaction. Please do it. Write all the possible product. Any answer? Mom, Austin, any answer?
No, sir.
Okay, I'm going to explain. First of all, you can say this carbon is directly connected with Br, so this will be your alpha. This will be your beta, this will be your beta, this will be your beta. So basically this beta is same. So what I'm going to do, there will be two products. So first I'm going to remove from this beta hydrogen and this bromine. So there will be double bond between these two. And the second product, I'm going to remove hydrogen from here and bromine. Then the next is double bond here and it will be CH2. So Humam, what do you think, which one is more stable?
Which one is what, sir?
More stable.
CH2.
No. Sir, how the name? Okay, I will tell you. See, along this double bond, this is a alkyl group and this is alkyl group. So this is major product according to SETJEF, and you can see along this double bond you have only one. So this is major and this is minor.
Okay, sir.
Yeah. Please do write it and let me know when you are done with this. Its name is methylene cyclohexane. Methylene cyclohexane. Is that clear, Austin?
Yes.
Okay. Moving to the next type of chemical reaction, and that is yours. The third one, that is reaction with metal. Reaction with metal. So first of all, there is a compound that is known as Grignard reagent. That compound has an original name that we call it organometallic compound. What we call it? organometallic compound. So basically what happens here, you can see, for example, Grignard reagent. This Grignard reagent is your organometallic compound, and how it is basically RMGBR. So basically whenever a metal has a bond with carbon directly, that is organic and metallic bond, organometallic compound, that is called. And this reagent, that the one I have written, is very important reagent that we call what we call RMGX. You can write RMGX. We call it organometallic compound, RMGX. RMGX. Is that clear? And you know, it is very, very reactive. That's why we put it in dry ether. As you know that metal is highly electropositive, so there will be delta positive, and carbon is electronegative, and halogen is also electronegative. So it is very reactive. It is so reactive, very reactive, that even a moisture react with it and convert this into hydrocarbon. RMGX is there. If you are going to react this with water, or moisture comes in contact with this, it will convert itself into hydrocarbon RH plus MgOH whole X, MgOHX. So I'm going to show you how this reaction took place. It's very easy. Basically, you can easily understand this. Like, let's say this is your RMGX, right? Now you know that this is your water, and water, that means it has two parts, H plus and OH minus, H plus and OH minus. You also know that this will have, this is metal, so it is electropositive, so the plus, and there is negative. So this positive will directly join with negative, and it becomes hydrocarbon RH, and this will be basically negative, so it join this, so it will be MgOH. Is that clear, both of you?
Yes.
Yes.
Please do write it.
Done, sir.
Very good. Now both of you have heard of Wood's reaction, right? So Wood's reaction comes under name reaction as well. Wood's reaction. Now you can see if you are going to react an alkyl halide with sodium in the presence of dry ether, you know what will happen? It will become double. Whatever is the number of carbon in alkyl halide, it will be double and it will be the byproduct. How the reaction will take place, you can see Rx. You are going to take 2 moles of Na as well as 2 moles of Rx. And I'm going to write this in opposite like this, the mirror image of Rx. Now what will happen here? This NaX will be eliminated. And in this way, this R and R will be joined together and 2 NaX can be removed. You will not be able to make, this is your dry ether, to prepare a hydrocarbon which contains odd number of carbon because it is doubling. If you have even number of carbon in alkyl halide, it will be even after doubling. Or if you have odd number of carbon in alkyl halide, that after doubling it will also be even. So you cannot prepare methane CH4 and alkane having odd number of carbon. Please let me know when you are done with this. Let me know when you are done with this. This reaction also, this needs to be remembered that when you are going to do the mechanism, you will see it followed by formation of radical. Formation of radical. Are you done with this? So this is also very easy. Chlorine, you can see sodium 2Na, and another is chlorine here. And what you need to do, just remove this and add this carbon directly to this carbon. So what you will get 1, 2, 3, 4, 5, 6. Hexane you will get. Is that clear?
Yes.
Okay. Can I change the slide?
Yes, sir.
Now see what we have. Now the next is basically we already have dealt with the preparation of halogens. Now we are going for chemical property of haloarenes. Chemical property of haloarenes. Now the first C. Aryl halides or haloarene, you can say aryl halides are extremely less reactive. Extremely less reactive towards nucleophilic substitution reaction. Since we studied about the nucleophilic substitution reaction of haloalkanes, that is quite good. But when we are going to talk about nucleophilic substitution reaction of haloarenes, it is very, very less reactive. So what is the reason behind it? So because of three reasons: a resonance effect. I will explain this. The resonance effect. Second will be difference in hybridization. Difference in hybridization. Difference in hybridization of carbon atom. And the third one is instability of phenylketone. Instability of phenylketone. See, the first effect. If you have a chlorobenzene, which is aryl halide or haloarene, so you know that this is basically in resonance with the benzene ring, and it is highly stable due to resonance. And in case of nucleophilic substitution reaction, this chlorine have to leave this benzene. And since it is stable, so it is not possible to remove chlorine. So resonance is one of the factor due to which it is very less reactive towards nucleophilic substitution reaction. Is that clear? Is that clear?
Yes.
Yes.
The next is your difference in hybridization. Let's say this is your haloalkane. So basically, you know that this is your sp3 hybridized, whereas this is your sp2, and sp2 carbon is just sp2 carbon is more electronegative, so bond is also very strong as compared to sp3. Due to electronegativity difference, it will hold together with the effect of charge. And last one, the instability of phenylketone. Let's suppose if you are able to, at any cost, if you are able to just remove this chlorine, you have to give a lot of heat energy. Then what will happen? Then phenylketone will form like this, and positive charge on double bond is highly unstable. That's why this haloarene or alkyl halide are very extremely less reactive towards nucleophilic substitution reaction. Is that clear?
Yes.
Please do write it. Let me know when you are done with this.
Done, sir.
Very good. Now see, but we are going to do this nucleophilic substitution reaction very hard to carry. So write a topic, a replacement by hydroxyl group, a replacement by hydroxyl group. Now, how you are going to do the replacement? So see, it's very simple, but the condition is very high, critical condition. This is your chlorobenzene, and if you want to remove this chlorine, see the condition is very critical. You are going to react this with NaOH at a temperature of 623 Kelvin and 300 atm pressure, and then followed by acidification, that means acid H plus. So this is how you can remove this, or nucleophilic substitution reaction can take place. But if you want to carry this in lower than this condition, there is a way, just attached NO2 group to this chlorobenzene. This is your chlorobenzene. As you know that NO2 is minus M group, which means it will withdraw electron from benzene ring, which will make this benzene ring or chlorobenzene more reactive. And due to more reactivity, you can see in the next one, that one I'm writing, will have low condition. You can see the temperature reduces, also the pressure also reduces, H plus. So you will get this as this. And if you want to reduce more condition, then there are other ways, like you need to add more NO2 group to this. Like let me show you what you are going to do. In the first one, it is without NO2. In the second one, it is with one NO2. And in the third one, I am going to introduce two NO2, which will make this ring more and more reactive. Now you can see the condition will be NaOH as it is, because we want OH minus, and the temperature decreases 368 Kelvin it becomes, and followed by, in the first step, this, and followed by acidification, that means in the presence of H plus. So what will happen here? The same reaction is carrying out. You can see this is your OH, and NO2 is there, and also there is NO. Now, if you want to reduce more and more condition, you can see what you need to do. Add 3 NO2 to this, and it will be highly reactive. That means basically, if you are going to pass this through warm water, the reaction can carry out. 3 NO2, due to this 3 NO2, since NO2 is electron withdrawing group, so what you need to do, just react it with warm water, and this will be replaced. This will be replaced. NO2 will be as it is. NO2 will be as it is. NO2 will be as it is. Please do write it. Let me know when you're done with this.
Done, sir.
Very good. Now I'm going to give some question to you. In the next class, that means on Thursday, we are going to complete this chapter. Ethane to bromoethane. Yeah, it is ethane. Ethane to bromoethane. Ethene. This
Okay, sir.
this is your ethane to bromoethene. Any answer? Both of you? I'm going to explain. If you want to prepare, you can say if you want to prepare, ethane has a formula this CH3CH3, and you want to prepare bromoethene, that means CH2Br, sorry, CHBr double bond CH2. This is what you want to prepare. Now, first of all, what I'm going to do, it's very simple, CH3CH3. I'm going to pass this through Cl2 in the presence of HNO. Cl2 in the presence of HNO. What will happen? Substitution reaction will take place and we will get CH3CH2Cl. Chlorobenzene we get. Okay. Now, after getting this, or you can we can directly use Br instead, so that we will be getting this Br2. We will be getting this. Okay. After this, what I'm going to do, I'm going to do alcoholic KOH. Alcoholic KOH and heat. So this Br alpha and this hydrogen, beta hydrogen, will be removed and you will be getting CH2 double bond CH2. Is that clear? And after getting double bond, there was a preparation of a haloalkane from alkene, in which we used Br2 in the presence of CCl4. Br2 in the presence of CCl4. So what will happen here? You can see this double bond will be broken and vicinal dibromide will form. Vicinal dibromide. Bromine will come here as well as bromine will be here. Now, after this, again, what you are going to do, again, you are going to do alcoholic KOH. Again, you are going to do alcoholic KOH and heat. Then you can see any one of the bromine from here and hydrogen from here, you are going to remove. So what it will be CH2 double bond CHBr is there, which means bromoethene, you got it. Is that clear, both of you?
Yes.
Let me know when you are done with this. Are you done with this?
Yes.
Yes, sir.
Okay. Bute 1N to Bute 2Y. Third one is ethanol 2. Ethyl fluoride. And then 1-chlorobutane 2 and octane. Just do it. I'll be back from washroom, please. Any answer? Mom, Austin. Okay, second one is very easy. Basically, you just need to convert that into haloalkane and use Schwartz reaction. Okay, I'm going to do this butadiene, butadiene, butadiene. That means you need to start from here CH3, CH2, CH double bond CH2, and you have to convert it into CH3, CH double bond CH, CH3. This is your butadiene. Now, how you are going to do it? It's very simple. First of all, you are going to do anti-Markovnikov. That means HBr in the presence of peroxide. So you know that in the presence of peroxide, what will happen? Negative part will go to that carbon which has greater number of hydrogen, and hydrogen positive part will go to that carbon which has lesser number of hydrogen. So hydrogen comes here and CH2Br. After this, no, just wait a minute. You are going to do it Markovnikov here. If you are going to do Markovnikov only in the presence of HBr, so according to Markovnikov, negative part will go to that carbon which has lesser number of hydrogen, and positive to that carbon which has greater number of hydrogen. So Br will come here and H will come here. Now after this, what you need to do, it's very simple. You are going to do alcoholic QH. You are going to treat this with alcoholic QH and heat. So you can see beta is here, but we need beta here, hydrogen from here, bromine from here. So you will directly get CH3, CH, double bond, CH, and then CH3. Is that clear, Humam?
Yes, sir.
Very easy it is. The third one is also very easy. You can see ethanol it is. So this is the formula of ethanol, CH3, CH2OH. And you are going to first treat this with SOCl2. So it will be CH3, or PCl5 you can use also, CH2Cl. And after this, you are going to use AgF, which is Schwartz reaction, and this chlorine will be replaced by chlorine. So ethyl fluoride it is. Oh, butane, just make it butane. For butane, you have to follow the reaction for what we say NaNH2 and liquid NH3. Let me know, Humam, when you are done with this. Austin, is that clear?
Yes.
Yes, sir. Done.
Okay. Now 1-chlorobutane and N-octane. You can see in the reactant you have 4 carbon, and in the product you have 8 carbon. So this is possible with only Wood's reaction. So what it will be double of the 4, 1, 2, 3, 4, 5, 6, 7, 8. This is how you are going to do it. Okay. Okay, for the next one, I'm going to give you. Let me know when you are done with this. You are going to do this propene to propane 1 or ester. Are you done with this? So it's very easy. Propene has a structure this CH3 CH double bond CH2. So first I'm going to react this with HBr in the presence of peroxide. That means anti-Marconi proof. So this will go here and this will go here. So what you will get, you will get CH3, CH2 and then CH2Br. After this, what you are going to do, aqueous chaos, nucleophilic substitution. So you know that this will have negative, this will have positive, this will have negative, this will have positive. So this will be directly attached with this. And you will be getting CH3, CH2, CH2OH. Is that clear? Plus
Yes.
NaBr will be there. So on Thursday, we are going to complete this chapter and please do attempt the NCRT questions. Okay.